Hello everyone, hope you all are doing extremely well. In today's video, we'll be going to see the question 2429, which is minimize or. In this question, what you have to do, you have given two numbers. Let's say the number one is n1 and there is one another number which is n2. What you have to do is that you have to find a number x, such that number of set bits in x should be equals to that in number of set bits in set bits in num2 in n2. So basically you need a number x where the number of set bits in x should be equals to the number of set bits in n2, and x XOR n1 should be as minimum as possible. This we have to minimize. So what is the intuition behind this particular problem is that eventually the x should contain the number of bits, the set bits equal to the n2. So first step to solve this question is to calculate the number of set bits in n2. Let's say the set bits in SB. SB is the number of set bits in n2. Now, if I want to minimize the XOR of x and my number n1, I can see one thing, that what is the property of a XOR. Whenever there are two set bits, the XOR will be 0. And if there are different set bits, 1, 0 or XOR 1 or 1 XOR 0, the answer is 1. Otherwise, in the cases when they are both the places the bits are set, the result is always 0. So my goal is to minimize that. Can I say one thing? If in number 1, if it is a 32-bit number, if I start iterating from the 31 bit to the 0th bit, and if I see if there is a 1 here, from right to left I'll go. I mean from left to right I will go, because the most significant bit is on the left side and the least significant bit is on the right side. So when we iterate from the most significant bit to the least significant bit, we will be eventually counting, we will be seeing where there is a set bit. If there is a set bit, we are also setting the bit in that x as well. Because suppose in my x, let's say, suppose in my x, if I set bits at these two locations, the XOR will be 0. And by using this approach, I can minimize the XOR as possible, because if I set the bit at different location, the XOR will increase. But if I want to decrease the XOR, I have to set the bit in x in the same position where there are set bits in n1. And I have to do until my set bits count becomes 0, because eventually I want the number of bits set in x should be equals to the set bits. Or I can do it till the 0th bit. That's the main thing. So the logic is just iterate from MSB to LSB, MSB to LSB, and put ones in X where there are ones in the N1. And suppose you end up in this 32-bit number. Now you have still some set bits remaining, some set bit counts are still remaining. So what you can do, you can iterate from LSB to RSB, LSB to MSB, and whatever positions in X having 0, whatever position in x having 0, just make it to 1. Set it until your set bit counts completely become 0. Because why I am iterating from LSB to MSB? Because I know that from iterating from LSB to MSB will start increasing my number from, let's say, 1 to 2 to the power something. But if I iterate from MSB to LSB, it will start decreasing my number. Since in the above case I want decrement, so I iterated from here, and now I want to increase my number, I am iterating from LSB to MSB. This is just a main logic for this question. So here you see I am just counting the number of set bits, which is equals to SB. And now initially I put in my X as 0. I'm iterating from most significant bit to the least significant. I'm checking if there is a 1, and also my set bit count is 0. I'm setting that bit in X as well. And I'm decrementing my set bits. And now if there are some set bits remaining, I'm iterating from LSB to MSB and I'm setting those bit in X. Hope you understand the solution. So it's just a bit manipulation question, I would say. Okay. So if you like the video, please subscribe the channel and press the bell icon for the more updates. Thank you. Bye bye.